Okay, take 2.
Okay, so we have this beautiful stack of pillow lavas, and I'm here with Gro, and we're going to find a good example and talk you through the formation of these pillows and some of the features you can describe in outcrop. And in contrast to some of the examples in New Zealand, which are millions of years old, these are much younger.
Yeah, so these are tens of thousands of years old, so they're quite fresh, and they form underneath the water. And when the magma comes in contact with the water, it cools very quickly on the surface and forms these glassy rinns, which is what is kind of defining the pillow shape here quite nicely. And you'll see they're more black and glassy here. And then you have basically the lava lobe as pillows here. And you see what is characteristic for pillow lavas, that we have a cooling which is kind of radial, because it's cooling from the outside where the water is, and it's forming these columns, which is often radial. So that's quite typical. I will think that these are basically lava pillows that are stacked on top of each other, so it's fed from below, but it's not very easy to see just from right here.
Perfect, and this is part of a huge stack, and we'll go over and see maybe the contact with some of the submarine tuffs.
Yeah, so the pillow lavas are erupted effusively, so non-explosive, and what we'll see in the other example is explosive submarine volcanism making the tuffs.
And this is a cross-section right through a submarine cone, and the pillows are forming part of the cone, and the tuffs are built on top or underneath?
They are built underneath here, so that can maybe be a little bit counterintuitive. You would imagine that you will get lower and lower pressure as the cone would build upwards, but there has been some reasons for the pressure to change to make the pillows later in the formation.
Cool, let's go and look at some of the tuffs.
I was thinking that is...
Okay, so maybe here we can see some evidence of tube-like pillows and beautiful glassy margins.
Yeah, you see these very elongated tubes here, or pillows, forming on top of each other, and you really get the feeling of this is a big stack. You see the glassy rinns very clearly here, and you even see that, you know, you have some of what we call pelagonite forming, where the lava has been quenched very, very quickly. So this is, some of the brown stuff, really. Yeah, that
classic yellowy brown colour that you see.
Yeah. You even actually see some of the crystals in here as well, the plagioclase crystals, clear. And then you see these big pillows, and here it's easier to see how they have been stacked, you know.
Great, let's have a look at some of that tuff.
Yeah.
Where are we?
Okay, so here we can see the boundary between the pillows above and the tuff here. Do you want to explain the some of the textural features of the tuff in front of us?
Yeah, so basically here we are going from effusive eruption into explosive eruption. And what happens is that the magma is fragmenting into pieces. And in this part here we see bigger grains of something that looks a little bit like scoria. And then as we, it may be more or less the same, but it's consisting of this pelagonite, which is fine grained, a little bit like sand, but it's really glass. And then these small grains of scoria-like features, and you can get stacks of this that is layered depending on how the eruptive activity, the intensity of the explosions have varied.
And maybe some of the finer grain layers are more turned to pelagonite?
Yeah, and we probably also expect the more finer grain to be the more intensive parts of the explosions.
So these are kind of like submarine, I wouldn't say airfall, I guess submarine kind of waterfall as they're settling out?
Yeah, exactly. And I guess you can also, if we are close to the vent as we would expect to be here, you can have surges of these coming down. So it can be more complicated structures than just perfect horizontal layering.
Yeah, because I guess some of this isn't super well sorted. You've got some kind of, yeah, you were saying scoria size class and then some ash size class, so maybe not perfect sorting. So cool.
Yeah.
Awesome.
Okay.
Okay, so we're still out on Rekenæs Peninsula, and here we can see where the subaerial volcanism, the younger Pahoehoe lavas, are being fed from dikes below, which are intruding through some submarine tuffs. So, Gro, do you want to guide us through this outcrop?
Yeah, so what you see here behind us is the tuff, which is the brown bit, the fine-grained stuff, which is the explosive submarine deposits, which was the initial stage of the eruption, which then, after this was deposited, we changed the eruption style. Suddenly we didn't have submarine eruption anymore, we had subaerial eruption, so the lava was erupted just under the normal atmosphere, no interactions with water or ice or anything. And that subaerial eruption was being fed by dike, and that dike you can see coming up through the tufts here. So that's this vertical feature. And then you can see the three layers of lava on top. And we will see the crater cone producing these lavas a bit later. What you can see as well is the dike itself. It has the characteristic chilled margins, so it's kind of darker on the sides of the dike, where it's finer grained. And then you see in the middle of the dike bubbles, so these are the vesicles. You also see that the tufts around the dike has been baked and is partly sticking out because it is more resistant to the erosion than the unbaked tuff.
So it's amazing to think that this dike, which is only a meter or so wide, is feeding these huge volumes and these sheets of Pahoehoe lavas above.
Yeah, yeah. This is quite impressive, and this is basically, I think, not unusual that you have the dikes doesn't have to be so thick in order to feed sizable eruptions, really.
Great.